Alright, this last video is going to explain how to work the gas law problems if you aren't really given full numbers, because our North Carolina final exam loves to give problems like this. The first example that I have for you is a problem that says, what happens to the volume if the pressure of a gas is doubled? And what they'll do is they will give you, A, B, C, D answer choices. They'll say things like, A, the volume doubles. B, the volume is cut in half. C, nothing changes. D, something's cut by a fourth. The way that you answer this and know for sure is to make up what I call dummy numbers. So it's asking me about pressure and volume. And if you look through your formula list, if you're using just pressure and volume, the only thing that I really have to work with would be this equation right here, PV over T. You had P1 V1 over T1 equals P2 V2 over T2. And so temperature is never mentioned. So what we're going to do is just take temperature out of the equation. And we can answer it with pressure and volume on two sides. I like to choose the number 1 just because it's easy to multiply with. So what I'm going to do is I'm going to put on the left-hand side that I have a pressure of 1 and a volume of 1. And on the other side, I'm going to make the changes that it says. It wants to know what happens to the volume if the pressure is doubled. So I'm going to take the pressure, which was 1, and I'm going to double it and make it 2. Then I'm going to solve for V. Well, 1 times 1 is 1. And so to solve for V, I end up with 1/2. So my volume from before would have gone from 1 to 1/2. The answer in this case is that the volume would be cut by half, or it would be reduced by 1/2. It would be divided by 2, whatever matches up with the answer choice that's listed there. Okay, you can choose other numbers. You don't have to choose 1, but you have to make it a something that works out. I recommend easy things. So let's look at another example here. It says, what happens to the temperature of a gas if the volume is reduced by half? So we're working off of the same exact formula here, except this time the thing that's not mentioned is pressure. So if I take the P out of it, I can rewrite it as, let's see, volume over temp is equal to volume over temp. So, okay, yet again, I'm going to do the same thing. I'm going to make it, pretend that they're both 1s, a volume of 1 and a temperature of 1. And ask what happens to the temp, I'm looking for T2, if the volume is cut in half. So, alright, I could put in 0.5. 1 was divided by half. And so if I end up doing this, this is going to be equal to 1. I'm going to have to multiply to get T over here. My T is going to be equal to 0.5. It's the only thing on the bottom that would still make it equal to 1. So the answer in this case is that my temperature would also have to be reduced by half. Okay, here's one more example. What happens to the pressure if the temperature is tripled? So I'm still working off of the combined gas law right here. What I'm going to take out this time is the volume. So this one's going to read P1 over T1 equals P2 over T2. And I'm going to be doing the same exact thing, 1 over 1. And if the temperature is tripled, so this time the temperature is going to become 3, and I'm solving for the pressure. So mathematically, I can rearrange 1 times 3, or I can use some common sense to go, well, it's got to be 3 over that to make it equal 1 over 1. So my pressure would be 3. So the pressure would also be tripled. You could let this serve you in any kind of circumstance where they don't seem to give you enough to solve the problem. Then make up your own numbers that make sense and are easy to work with, and you will know for sure what your answer should be.